Hello everyone, thank you for taking some minutes of your time to hear me. My name is Carmen, I'm a researcher in the Cementir Holding, and today we are going to talk a little bit about 3D concrete printing, the fundamentals. Our topics today will be what is 3D concrete printing or 3D CP, the main advantages of the technology, the 3D CP simplified process from a general perspective, and then more into the material perspective, which is my real area of expertise. Then I will explain a little bit our doings as a company on the 3D CP world, and finally my opinion on what could be on the future for this very amazing and interesting technology. So bear with me while I take you to a short journey on the 3D CP world. Okay, so let's start with the concept. 3D CP is an emerging technology that combines digital and materials technologies to allow free-form construction without the use of formwork. And this is a key point of this technology. 3D CP is also a type of additive manufacturing technique where the construction is through layer by layer addition of material. Most 3D printers worldwide are extrusion based, meaning that the mortar or concrete is dispensed through a nozzle. Now I wanted to highlight some advantages of the use of this technology in construction. For example, the reduction of construction costs by eliminating formwork. This is very critical, especially for projects with very challenging shapes, for example, Zaha Hadid building, because it might require hundreds of different formworks. Second, reduction of injury rates by eliminating dangerous jobs. Also, the creation of high-end technology-based jobs, minimizing the chances of errors by precise material deposition, increasing sustainability by reducing waste. Let's remember again the case of the formworks. If we don't use them, we don't need to discard them. Increasing architectural freedom. I think this technology will be the dream of parametric architects worldwide. And finally, 3D CP allows a structural architectural multifunctionality of elements due to the freedom to make complex shapes. Now we will go into the physical printing process that takes place on a normal production day. Please be aware that this is a very simplified explanation of all the processes that happen to print an element. First, someone designs the structure or element to be printed and feeds this information into the printed softwares. And this is a very oversimplified way to explain this process, since lots of digital tools and research has been done and is still going on to optimize these first steps. Then we have all the raw materials as binder, filler, supplementary cementation materials, aggregates, and mixtures that will create the mortar or concrete to be used. These materials are mixed either using a batch mixer or a continuous mixer, which is the choice of the producer. Then the material is pumped to the nozzle where the printing process starts, and then the element is produced. Like with any other concrete production, every product needs to comply with the intended geometry and also mechanical properties. From the material perspective, a lot is going on. For example, once the raw materials get in touch with water during mixing, the hydration of the mortar or concrete starts to happen. I would like to give credit to the researchers and companies around the world working with 3D CP. I truly believe that the main factor contributing to the success of this technology in short time has been the R&D efforts by all the different players. From private companies to universities and research institutes, a multidisciplinary approach has been implemented, combining many tools and disciplines such as robotics, numerical simulation, software development, and materials technology. Now the focus will be on the material side of the process. The producer is the one targeting the properties of the mortar or concrete in each phase because it needs to fit their own production method. That is the reason why I cannot give any target values to fresh or mechanical properties. In the table, the process is broken into 8 steps, and for each step, the material requirements are specified. I invite you to pause the video and read each step in material requirements. In summary, we need a robust, non-segregating pumpable mix during steps 1 and 2. Then, the mix is activated with admixtures to make it strollable and buildable. Processes 4 and 5 need a mix with a controlled setting, where the filaments have a good bonding and each layer can withstand the next layer on top. The final 3 stages, setting, milling, and hardening, also require a controlled set and hydration reaction. It is important to consider shrinkage of the mix to avoid cracks. Due to all the processes involved during 3D CP, I would strongly recommend targeting the fresh and hardened properties of the material on each phase, and also the final mechanical properties, so the production process is more traceable and the quality of the product can be guaranteed. On the other hand, this amazing picture, courtesy of the Danish Technological Institute, is an example of the advantage of using white cement in 3D CP to get a highly aesthetical element, playing with different color shades. I wanted to dedicate a couple of slides more to the important properties to target in each stage. In the case of pumpability, the most important is to get a robust mix with no signs of separation. One way to guarantee this might be to fix the water to cement ratio and find the right amount of superplasticizer to get a target flow and flow retention. The target flow will be associated to a mix that the user not know it will be pumpable. For all the other processes, we know that the mix must be extrudable, buildable, it needs to set and to gain strength. Some key points associated to these processes. Admixtures are a key element for 3D CP. Superplasticizers, accelerators, retarders, air entrainment admixtures, defoamers, stabilizers, rheological modifying admixtures, shrinkage compensation. Control of the rheological properties is key for extrudability and buildability. Control of setting rate by using retarders or accelerators to fit the specific application. Fix water to cement ratio and air content to get a target strength. Many of the robots available allow the introduction of admixtures just before the nozzle through a dynamic mixer. And with the previous slide, I finished the technical aspects of 3D CP. Now, I would talk a bit about the approach of Cementir towards this technology. We are working on gaining the technical expertise needed to support our 3D CP customers worldwide. As part of this initiative, we are participating in a project run by the Danish Technological Institute called NextCon. And our main function is to provide the cement and the technical support related to its use. This project aims at developing technologies that bring 3D CP to an industrial scale, with a clear focus on sustainability and new architectural designs. Positive results had been achieved by using all white cement and our new cement technology, FutureCem. I wanted to dedicate one slide to our new cement, FutureCem. If you are interested in knowing a bit more about this sustainable cement, please go to our website. FutureCem was also tested in the NextCon project, showing very good results. This cement is suitable for 3D CP applications in both versions, gray and white. Sustainability-wise, a change in the main binder from a CEN 152.5 end cement to FutureCem features circa 30% reduction in CO2 emissions. If we talk about white cement, then the reduction goes to 45%. So it will make a lot of sense in terms of sustainability to choose FutureCem over traditional cements. Finally, let's talk about what the future might bring to 3D CP. The technology will continue growing exponentially worldwide. R&D projects will allow new applications and continuous improvement. This technology might be established as the preferred alternative for social constructions in developing countries. One of the main challenges and action points for the main players is and will be to comply with current regulations. Maybe it will require the update and revision of them once the technology is widely spread. Well, this is the end. I hope you found it interesting. Thank you so much for listening and see you next time.